Right. Thank you. And that did not go as planned, but here we are. So I want to talk about distributed tracing in Go, and this is me. I just took a picture. So please, photographer, take a picture of this so I can show to my mom and my dad that I actually presented something, right? But yeah, my name is Hungai. I'm from Nairobi, Kenya. I work for a company called Lightbend. We're in the JVM space, but on the side, I do Go, hence why I'm here. But whatever I'm going to be talking about today is basically what I do on my day job. It's just that I do it in Scala and Java instead of Go. But on the side, I do it in Go, consulting. So if you're ever in Nairobi, there's a couple of people from Nairobi over here, but just reach out to me on Twitter. That's my handle. I'll be more than happy to show you around. Sounds good? Yeah, I have to market my country. Like, seriously. Yeah. Okay, so just to get a sense of the type of audience in the room, I'll ask a few questions. Is that okay? Right? So how many of you work in ops? Nice. How many of you have heard about distributed tracing before? Nice. And how many of you have implemented distributed tracing in your company? Okay. All right, so for the last people, I want you to hold me to a standard. If I say something that is not truthful, please call me out on Twitter or just stand up and do it, right? Yeah. Okay, so a bit of history. For quite a while, we've been developing applications as monoliths. So this would just mean a single process, a single runtime, and we just needed logs. Like all you had to do was add some context in your logs, and that's enough to do some root cause analysis or to do some debugging, right? But then we shifted away from monoliths because of either scaling people within the company or just wanting to run one single process within one runtime. And we moved to microservices. So this would mean having one service handle one process. And this introduced a couple of challenges, especially in ops. This is really good if you're a developer, because all you have to care is about your service. But if you work in ops, it's a whole different problem, right? Because as a developer, you're just dealing with something in development. In ops, you're probably running service A, 5 instances or 10 instances, and you have to manage that. So on the ops side, it's kind of tricky, right? So imagine that, just a small story to get a sense of how this would work. So imagine that you're requesting a car from a ride-sharing service like Lyft or Uber. I think most of you are aware of that. Your request will hit the Lyft servers, and they'll try to get a car, and it begins trying to get a car for you. So it takes your geolocation and passes the geolocation to a service that finds a car that is nearby and puts all these cars into a list, right? The list of cars is sent to another service, which sorts the list of cars and how close they are, so proximity-wise. And then finally the list of cars is sent to another service that will send a response back to your phone, right? Disclaimer, I don't work at either company, so this could be wrong on how it happens, but just as an example, right? So in the example, all we did was took a geolocation, turned it into a list, sent it to another service, so they sorted the list, and then sent that sorted list to another service that sent back to a response to a user. So moving from a monolithic application to a microservice architecture, we now see that there's a lot of services that are involved in serving just one request. And when one service fails, we have to know where to look at, right? We have to know where to begin. Because I think there's a quote I read about how debugging microservices is almost like you being a detective and investigating yourself as being the person who committed the crime. So we have to know where to begin, right? When one service is not delivering or it's slow, how do you know where this latency is coming from? So the solution to all this is distributed tracing. So this is the definition on most of Wikipedia and places out there. So, but what exactly is distributed tracing? Fundamentally, it's about tracking and analyzing requests as they bounce around different services as a whole, right? This is in contrast to traditional ways on how we did monitoring, which would just focus on a single service as an individual in isolation. If we're collecting logs for that, we just collect the logs for that service in isolation, or and this favored aggregate metrics of how. So you wouldn't understand the life cycle of a request, right? So when service, for instance, in our example, when service A calls service B, it will hand off request ID. This is if you're doing distributed tracing, so that the overall request can be traced as it passes through the different services. Sorry. So the time that a request would spend on each and every of those services is what we call a span in distributed tracing. So this has a start time and an end time, and that is measured for purposes of either latency or performance analysis. So, and if a request is to hit 20 services, we'll have generated 20 spans, and those spans are collected into something we call a trace. And we evaluate the trace for either performance, latency, and all the other good stuff, right? So why tracing? You can use tracing to do performance analysis. An example would be to find in your chain of services which service is the slowest. With distributed tracing, you can be able to identify that using spans. Which span is taking the longest time to execute? Can we find a way to optimize this? Is this service in your critical path? And do we need to add more machines, or more? Do we need to spin up more services that can be able to handle the load? So with tracing, you can be able to do that, right? You can also be able to do anomaly detection. You can do profiling. And you can do resource attribution. So I'm trying to just go over the slide to beat time. But anyway, so with resource attribution, if a service is in your critical path and you want to either increase the performance of that, this would show you, and you can be able to move around resources or prioritize on resources. So if you had initially put resources to a service that is not really using a lot of resources, it might be easier to reassign those resources to a service that is in your critical path to be able to, I guess, handle the load, right? So I've already introduced some terms, but the most important one is a trace, and this is how a trace would look like. So it tells the whole story from when a request would hit your service to getting back a response, right? And a trace is a story of a request journey through your system, and incoming signals in your distributed service will always trigger some actions. So those actions are what we call, or events, or a sequence of events. So the sequence of events is called a trace, or it's collected to be a trace. And a trace is composed of spans. And this is what a span would look like. So it's just a single operation from maybe service A to service B. Should have used better diagrams, right? And each service that a request touches contributes to the trace as a span. And a span is just a named operation with a start time and end time. But you can always add more annotations to add specific context. So this would be user demographic information, or whatever can help with debugging. So in the grand scheme of things, all spans will share the same trace ID, because a trace is just a directed acyclic graph. And to be able to collect that, we need to have some sort of correlation. And a trace ID, when the request first hits your service, a trace ID is generated, and a span ID is also generated. And a parent ID is nil because it's the first time the request is hitting your service, right? The next span that will be generated will have a trace ID that was generated. So the trace IDs is passed to the next service out of, but it could be through headers or, yeah. So now we have a parent ID, which is the span ID from the previous service, and a new span ID is generated. And this would go on and on and on and on. So a tracing engine will collect all this information and be able to visualize it because of the ID correlation. Yeah. Okay. So I thought that image will not be clear, but this is a more clear image of how the spans would look like. Right. So if distributed tracing is so good, why isn't everyone using it, right? One, the biggest issue has been lock-in, is vendor lock-in. There's a lot of vendors that, distributed tracing is really hot right now, so there's a lot of vendors trying to either implement their own implementation, and so people are afraid of being locked into a certain vendor or a certain technology. Then there's inconsistent APIs. There's a lot of, for instance, this would be the APM service provider A has a different semantics of, compared to APM provider B, who has different semantics. A good example would be maybe AWS X-Ray. It's completely different to how everything else is named, right? And three is, we're in a world of microservices, so there's a lot of different runtimes that applications run on. So there's a lot of people don't want to start again re-implementing tracing APIs on different services that they're calling downstream, right? So there's some work that has gone into trying to solve some of these issues, and one of them is the open tracing standard, right? It's all they're doing is it's an API, it's vendor neutral, with a lot of participation from all these different APMs, so that they can have one single language or set of APIs that everyone can implement, so that you don't have to again re-implement tracing APIs when you decide to move to a different vendor. It still just needs to work out of the box. So there's open tracing and open sensors, and now we have open telemetry, right? Open telemetry is open sensors and open tracing came together because now they were all pursuing different goals, and we needed to come, or they needed to come together to be able to at least have one single API that will be the source of truth for distributed tracing. So when you're doing this in Go, just some things to keep in mind. I think a few speakers have already spoken about this. Just make sure to pass the context as the first parameter in your function. This is not only good practice, but it allows the tracer to retrieve information from upper level spans down the stream in your function, right? Two is tracing should not affect the normal flow of your application. So if you have a function that does X, Y, Z, but tracing or errors from instrumentation code should not affect how the function works or the output of the function. Right? Then again, tracing should not really introduce a lot of overhead to your application, even though monitoring still has some performance overhead in your application. You don't need to trace each and everything in your service, because if you are running 10,000 services, then that's a lot of traces, right? So you need to find ways that you find functions that are in your critical path or functions that are important to you, and then trace that, right? Okay, so I'm gonna try do a demo just to show what this is. So it's two services. I have an item service and an order service. Both services have separate instances as their data store. In this particular case, I'm using Redis as for persistence. And when an order gets placed, the order service contacts the item service with the list of the requested stock, right? Hopefully it's better than the first time I did it, trying to, yeah. Oh God. So I have some JSON of just popular books in Go or services. I think I should have shown the code first instead of this. Okay, so in this example, okay, so this function just retrieves. Yeah, retrieves all items from the database. We start a span. Yeah. No. It's not working. Yeah. Okay. So line 38. Okay, so just first you need open tracing, the open tracing import. We need to define a tracer, which it's defined somewhere else. But in line 38, we start a span from the context, which is just get all items, and then we have defer, which when we finish the function, we need to finish the span, right? So this does not. Okay, there we go. So this works out nicely. So I'll be using Jaeger as the tracing and backend. So if you look at our traces and that, actually let's look at the, yeah. we can see that this generated 15 spans, and we get a sense of how long the request took. We can look at if you had tags or annotations, you can look at that. You can see like all the steps that were called and how long each span took. And this gives you an idea of like the first, this took longer than the rest, and you'd want to find out why it took longer than the rest. Another service, that order service, you can also, nothing. Gives you a sense of the request, how long it took, and the method it was able to call. And yeah. Oh, God. And yeah, that's distributed testing. Thank you.